Dear grade 11 students, so how are today? I'm hoping that all of you are doing fine and safe at home. So for this day, we're going to discuss about computing interval estimates for the population mean. An interval estimate is also called as a confidence level. So there are three commonly confidence levels, which are 90%, 95%, and 99%. The interval procedure or the interval estimation procedure is summarized using the 7-step process. Step 1, describe the population parameter of interest. Step 2, specify the confidence criteria. Step 3, select the level of confidence with corresponding coefficients or critical values. Step 4, collect sample data and find the point estimate. Step 5, find the margin of error and, of course, compute the interval estimate. And step 6, we need to describe the result. For example, we're going to use this example. A random sample of 100 students are asked how much they spend for a meal during weekdays. The average spend is found to be 75 pesos. Past experience has revealed that the population standard deviation is 5 pesos. Find the point estimate and the interval estimate of the population mean using the 95% confidence level. The formula that we are going to use is the margin of error is equals into positive, negative. Your critical value, wherein you have the alpha over 2. And then, of course, we have here to multiply it by the standard deviation all over the square root of 9. So we all know that we have here positive, negative 1.96 since we have their 95% confidence level. So to be multiplied by 5 as our standard deviation all over the square root of 100. Of course, that is your sample size. And then we have their positive, negative 0.98. How it becomes positive, negative 0.98? Because 1.96 multiplied by 5 all over the square root of 100 is 10. So you multiplied it, so that's why it becomes 0.98. So that will be your margin of error. And then after that, we're going to compute for the interval estimate. In finding for the interval estimate, so we have here mean is of course greater than our mean minus our critical value to be multiplied by the standard deviation all over square root of 9, of course, is greater than, but less than the value of the mean plus your critical value to be multiplied by the standard deviation all over square root of your sample size. So how it becomes that? For us to really understand that, so we have here the mean minus, of course, your critical value is 1.96 to be multiplied by 5 as our standard deviation all over square root of 100 as your sample size. Then, of course, so we have here our mean, but of course, it is less than the value. So we have here the mean plus 1.96, of course, to be multiplied by 5 all over square root of 100. We have here 75 as our mean, minus, of course, 0.98. How it becomes 0.98? So you have 1.96 times 5 all over the square root of 100. So that's directly. So we have here 0.98. And then 2, of course, so we have here 75 plus. So this will be 0.98. And then, so we have here 75 minus 0.98. So we have 74.02. 2, of course, 75 plus 0.98. So that is 75.98. So, of course, for our step 6, using this, we can say with 95% confidence that the interval between 74.02 to 75.98 contains the population mean based on the sample size of 100. Expenses on meals range from approximately 74 pesos to 76 pesos. Okay, class. So, for example, you're asked to complete this table, wherein we have there the given 5 random samples of size 20 with a standard deviation of 1.2. So, we have here a 4-column table, wherein the first column stands for the sample number, second is for the sample mean, and then the third one is for the 95% confidence interval estimate for the mean, and the 99% confidence interval estimate. So, we are going to complete this table. So, let us have the first example, 4.5 as your sample mean. Using this given example, the first thing that we are going to do is we are going to find for the margin of error. So, of course, using the formula, margin of error is equals into the critical value to be multiplied by our standard deviation all over square root of your sample size. So, let us have first the 95% confidence level. So, we all know that if we are going to use 95% confidence level, so therefore, the critical value here is 1.96 to be multiplied by our standard deviation, which is 1.2 all over the square root of 5 as our sample size. And then, so 1.96 times 1.2 all over square root of 5. So our margin of error is equivalent into 1.0518. So this will be the margin of error if we are going to use the 95% confidence level. And then, of course, so let us use this also for finding for the margin of error using 99% confidence level. So same formula, we are going to use the margin of error is equals into the critical value to be multiplied by our standard deviation all over the square root of our sample size. So we are going to use, of course, the critical value, if we're going to use 99% confidence level, is 2.58. To be multiplied by 1.2 all over the square root of your sample size, 5. So we have here the margin of error as 1.3846. Okay, so we are going now to use this in finding for the interval. Let us have first the number 1 example wherein the sample mean is 4.5. So of course, let us have first the 95% confidence level. So we are going to have the interval estimate as we have the mean, of course, minus of we have the critical value to be multiplied by the standard deviation all over the square root of n. Of course, we all know that our mean is less than or equals into this, but of course, we have here the mean, then plus the critical value, okay, to be multiplied by, of course, our standard deviation all over square root of n. So still, we're going to use this as our margin of error, okay? So we are going now to have here our 4.5 as our sample mean. So we have 4.5 minus. So of course, we all know that we have here the margin of error as 1.0518. And then, of course, we're going to have 4.5 plus 1.0518. So therefore, 4.5 minus 1.0518. So this is equivalent into 3.4482. And then, of course, so if you add 4.5 plus 1.0518, so we have here 5.5518. So therefore, class, we're going now to have the interval estimate as 3.4482 to, of course, 5.5518. So our mean is greater than 3.4482, but of course it is less than 5.5518. So continue the process until we get the 95% confidence interval estimate up to this sample mean. Let us have the second sample mean, which is 3.2. So same margin of error that we are going to use. So therefore, we are going to have here 3.2 as our sample mean. Of course, minus your margin of error, which is 1.0518, is, of course, our mean is greater than, less than, okay, greater than. Then, of course, we're going to have here 3.2 plus 1.0518. So, therefore, 3.2 minus 1.0518 is 2.1482. And then, of course, 3.2 plus 1.0518 is 4.2518. So, therefore, if your sample mean is 3.2, so your 95% confidence interval estimate is from 2.1482 up to, so 4.2518, okay? Let us have the third example wherein your sample mean is equivalent into 4. So same process, so we have 4.0 or 4 minus, of course, our margin of error 1.0518 to get the interval estimate, of course. So this will become 4.0 plus 1.0518 as our margin of error. So this is equivalent to 2.9482. But of course, it is less than 5.0518. So therefore, so this is 2.9482 up to 5.0518. Okay? And then, of course, continue the same process into 3 and 3.1. So as we continue the process, or same process, so we arrive as 1.9482 to 4.0518 when your sample mean is 3.0. And then when your sample mean is 3.1, so therefore your interval estimate is 2.0482 to 4.1518. Let us now continue getting the 99% confidence interval wherein our margin of error arrive as 1.3846. So of course, we're going to have the interval estimate wherein we have the mean is of course less than our the sample mean minus our critical value to be multiplied by our standard deviation all over square root of our sample size. But of course, it is less than of course our sample mean plus your critical value to be multiplied by your standard deviation all over square root of your sample size. So of course, as we arrive as the margin of error, so we have here the sample mean as 4.5 minus, we have the margin of error as 1.3846. And then, of course, we're going now to have here 4.5 plus 1.3846. Okay? So, we are now going to have here 4.5 minus 1.3846 as it is equivalent, of course, into 3.11. We have here 1154. But of course, it is less than 4.5 plus 1.3846. So we have here now 5.8846. So therefore, your interval estimate in this given example is 3.1154 up to 5.8846. And then continue the process. So of course, we are going to arrive as using 3.2. So we're going to have 1.8154 up to 5.0154. And then, of course, in the third one, using 4.0 as your sample mean, so that is equivalent into 2.6154 up to, so we have going to 5.3846. And then we continue using the same process. So we arrive as, if you are going to use the sample mean as 3, so you have here the 99% confidence interval estimate as 1.654 to 4.3846. And then if you have the sample mean of 3.1, so you have here the interval estimate as 1.7154 to 4.4846. Okay class, so that is how you are going to compute for the interval estimates for the population mean using the 95% confidence interval and confidence level, and of course the 99% confidence level. So if you do have question, please do not hesitate to ask your teacher. Again, thank you for listening. God bless and stay safe.